Okay. So thank you for joining, you guys. I see 13 participants. My goal today is to talk about some key concepts that we learned during the semester, and that'll be kind of my focus for the final exam. The final exam, as you know, is 30% of your grade. So it's going to be similar logistics as we had for the second midterm. So it'll be posted at 12 noon. It'll be due after 12 hours. So that 12-hour slot seemed to have worked very well in for the second midterm, and I'm going to continue to use that time slot for the final exam. It will be written as if it was a 3-hour exam, but you will have the opportunity to extend that, check your work for a 12-hour time period. So it'll be posted on Piazza, the same as midterm 2, and then we will have the submission on Gradescope before 11:59 p.m. on the same day. It's going to be open book, open notes, open laptops. However, just as midterm 2, this is an individual assessment. It is going to be comprehensive exam. So all the things that we learned over the course of the semester, uh, you know, the more important stuff is going to be tested on, but it is going to be comprehensive. So all the material is fair game. Now, during the exam, please write your full name and your written number on every page of your submitted work. That helps with the management of whether everybody got in there. So that it's convenient to keep track of who submitted what. So uh, please make sure you do that. Um, if you have a question during the exam, please email me. Don't post it on Piazza. This is important because this could lead to unnecessary confusion. So, for example, if I have a question during an exam and if I post it on Piazza, somebody who didn't get confused might get confused after looking at that question. So I encourage you guys to directly email it to me. And as you know from midterm 2, my turnaround time for the questions has been relatively quick. And I promise the same for the final exam. So, you know, you can expect my response within 1 hour, which is also a worst case scenario, but within 1 hour, you can expect my response. Actually, Piazza, I don't know if some of you have noticed, but in the last week or so, Piazza started offering this service to instructors about the exams. So now instructors can go in and lock the web page, the Piazza tool for the duration of the exam. So they implemented that for all the Piazza users. I'm not going to be using that. I trust you guys to do it to email me directly anyway. So I'm not going to be locking the course so that you don't have a ability to post. But if in case we have a common question or a typo, we had one case on the second midterm. If that is the case, then I will post something on Piazza about the clarification for that particular typo or a common question, and you will get an email regarding that. So from maybe 2-3 hours, every 2-3 hours, just keep a check on any posts from me to make sure that you are not working on something that is incorrect. Okay. Be sure to show your work for each of the problems. It is very difficult for a TA to gauge your assumptions and your thinking. So put those things down unless they are extremely obvious. But if you are if you are doing some calculation in your head, make sure that you just explain your thought process. And if for any problem you have to make certain assumptions, then please state those clearly. Those assumptions should be reasonable. It's not like I can take any problem and start with writing assumptions. Those assumptions should be reasonable. Okay, so as we go through this, if you have any question, then you can feel free to type it in the chat box. I'm keeping track of that. Or if you want to save it at the end, where I'm going to open it up for questions anyway, we can talk about that, talk about it then. So next, I'm going to lay out the main topics. Now, this is a list of topics that I feel are the most important. This is not each and every subtopic. This is a general list. And on this slide, we are looking at all the content that is related to computer architecture. So we started with CPU performance, right? Like computing the CPI, or how do you measure MIPS, the million instructions per second. So comparing processor performance. So we did all of that in the beginning of the semester. One or two classes were dedicated to that. Several homework problems were dedicated to that. However, we didn't have questions regarding that on exam one, and several of you were upset about that. So I will try to make that up for the final exam. So you can definitely expect to see a question on CPU performance, where you will be asked to work out the CPI, the average cycles per instruction, and so forth for processors, and to compare their performance. Then we looked at MIPS assembly code. So we looked at the R, I, and J type instructions, conversion from C to MIPS and MIPS to back to C. Trying to work out a MIPS code that has fewer number of instructions. So you guys did a few homework problems. You definitely looked at those aspects in the first midterm. So that's going to be, again, an important part of the final exam. And then a relatively easy topic of number representations. You guys already were exposed to the 2's complement number representation from COCO, but we went into the IEEE 754 standard in the number representations chapter. So we looked at the 32-bit single precision format and the 64-bit double precision format. So converting numbers from decimal to one of those formats and back, that's going to be there on the exam as well. Then we started looking at how the data path of the CPU can be organized, the control unit, and how all the pieces, memory unit, ALU, the program counter, the various aspects that go into a computer, how they play along with each other in data path followed by control. Those were lectures leading up to the topic of CPU pipelining. So when we looked at pipelining, we looked at our main goal was to essentially utilize almost all the resources of the CPU all the time. So that was the main goal there. And while we are executing certain instructions, we looked at certain data hazards or certain control hazards that could happen. And for the control hazard or the branch hazard, we looked at how we can sort of risk prediction and reduce the penalty that we pay for branching early. So again, an important topic, a lot of block diagrams to go over, followed by the use of cache and memory hierarchy. So how can we reduce latency, average waiting times or average access times by implementing a very fast but small memory that is present very close to the processor, on the processor chip, and then going down in that hierarchy to the secondary memory or the hard disk. So calculations based on access times will appear on the final exam. And then we looked at a topic which has helped us transition from computer architecture to operating systems, which was all related to memory. So, page management or page replacement algorithms. How can we store things in memory and ensure that no errors have occurred to the bits sequence that we stored using the Hamming error correction, error detection schemes, and then reliability and cache coherence that we looked at using one protocol, the snooping protocol, and then we just looked at an alternative in the directory braced protocol. In terms of page replacement algorithm, we looked at a few like first in, first out, uh, least recently used page replacement algorithm. I believe we also looked at the optimal algorithm, which was essentially a theoretical algorithm, not practical. And then we looked at the approximation to LRU in terms of the second chance, first in, first out algorithm. So those are topics that follow a particular structure. So in my opinion, those are not particularly hard questions, difficult questions. They follow a structure, they follow an algorithm. So knowing how to work through those numbers, which you guys did in homeworks and activities, should be very good practice for those topics. So that was essentially 5 lectures on memory that helped us transition into the next main topic, which was the operating system. So over here we looked at how do we create new processes using the fork system call in Unix, and then how do we use exec system call in Unix as well to change the code inside the child process. And then we moved on to inter-process communication. So how can one process communicate to the other using shared memory, or um, using shared memory, right, or message passing. So we looked at message passing in detail with the implementation of pipes. Then we went on to process scheduling, so CPU scheduling. How can a CPU be assigned to certain processes and on what basis? So we looked at, if I remember, first come first serve. We looked at uh, shortest job first, which was again a theoretical algorithm, not a practical one. And then we looked at a practical, very good algorithm of shortest remaining time first. Then we went to CPU deadlock. So conditions, there were 4 conditions, necessary conditions that guaranteed a deadlock in a system. So we looked at resource allocation graphs, and wait for graphs in the case of single instance per resource, um, that could help us figure out whether there is a possibility of a CPU deadlock or not. We looked at deadlock prevention. We looked at deadlock detection. We didn't go over deadlock avoidance, but we mainly focused on deadlock detection and prevention. For deadlock detection, we looked at the algorithm, which was based on the banker's algorithm for safety. So, safety algorithm as it is listed in the textbook. Pretty straightforward. Again, you're trying to keep track of the available resources and then trying to keep track of which processes can get executed depending on how much we have available. So that was on deadlock. And then the last thing that we looked at was the file system, which a lot of theory in there, some numbers only when we had to compute the bit vector, so free space management. We did that in the file system chapter. Um, so that is all the things that we went over the course of the semester. We didn't go over the networking aspect of the course, and as I indicated on the Piazza post, once we started losing classes, we lost 2 classes after spring break. The only way to kind of bring about a smoothness or a flow to this class was to focus on operating systems. So I have posted very reliable, very good resources on YouTube that talk about computer networks. And the textbook that I listed, A Top-Down Approach to Computer Networks by Kuros and Ross. Jim Kuros was, I believe, Professor Vastola's student. So he was a distinguished lecturer in our department. The main author for that book. It's a very good book. It's a very easy read. I would recommend you guys to read through that, depending on your interest, of course. So the first unit actually goes over the topics that were meant for this class, and then depending on your interest, whether you want to go into the unit 2, 3, and so on, depending on which layer you're most interested in. So for example, me being a communication engineer, I was most interested in the physical layer. So I went all right down to the physical layer. But if you are interested in the application layer or maybe the network layer where routing and switching happens. So depending on your interest, and you will figure that interest out as you are going through the unit 1. So I would encourage you guys to explore those topics depending on what you're interested in. But those are very good resources that I pointed out. Springer actually has free textbooks, and if you are they have made free textbooks available for a short duration of time. And so if you want to look at the book that I mentioned, it is right now for free on Springer's website. So if you want to know more, just send me an email and I will point you to the link. Okay, so how do I study for the exam? So this is what I'm recommending in terms of study material. So there's a lot of you know resources that I'm going to be pointing you to. However, each of you should evaluate your strengths and weaknesses and then go over these study materials. So the first point is going to be lecture notes. So all of them are posted on Piazza. Some of them have not been posted after the lecture, and those are the ones where I didn't write anything. I essentially walked you through a set of slides. Mainly the operating systems lectures where there was not much to write on the slide. So those don't have the after the lecture slides. Those just have the before the lecture. But all those slides are available to you, and uh, go over them depending on which topics you feel comfortable with and versus which topics you don't. So if I was studying for this exam, I would first go over the initial part of the course, which was lecture 1 through I believe 13. That's when we stopped just before the spring break. And I encourage you guys to focus on the first 13 lectures more, just because this was a while ago, and the remainder of the course was relatively new, and you guys actually went through the second midterm recently on some of the lectures, but the first 13 lectures was a while back. So try to get a head start on those lectures early. Then I would say homework and activity. I'm going to focus my questions such that the skills that you have learned while going through the homeworks and activities are going to be the main tool for you to be able to answer the questions on the final exam. And I'm also listing the sections from the textbook. These were assigned to you throughout the semester as readings. On this slide, I have the ones from Patterson and Hennessy, which was our main computer architecture textbook. And on the next slide, I have the sections of the textbook for operating systems that we followed. Now, these sections that I'm mentioning, these are not in any particular order. So in order to bring about a good flow in our semester, we kind of jump back and forth. So we went from chapter 1 to 2 to 4 to we came back to 3. So this is not in a particular order. I'm just listing them the way they would be listed in the contents for the textbook. But those are essentially the sections that we focused on from the textbook. This is the 5th edition, of course. Let's see. Another thing that I would point out is, suppose you are very comfortable with all these things, right? I know all these things. I'm an expert at what you taught me. I'm an expert at. I have reviewed all my homeworks, activities. I'm done. What do I do next? So if you look at the textbook, at the end of the textbook, there are very good problems for you to take a look at. So I would encourage you guys to try to solve those problems depending on how much time you have. But this is the things that are appearing on this slide. Those are going to be the first sort of the main study material that I would recommend. Let's see. Then we have all these are essentially sections from the operating systems textbook, Silberschatz, Galvin, and Gagny, and the lecture videos for operating systems and some of the lectures from computer architecture. They are recorded. They are on YouTube, so you can review that depending on, again, your strengths and weaknesses. Okay, so I guess a lot of you wanted to know how is the exam going to be distributed in terms of the material that we went over. There is no, there's no very clear breakup I can provide, but I can provide you a rough estimate on my goal. So my goal is going to be to focus 35% of the exam on the material that was covered before midterm 1, and then 35% between midterm 1 and midterm 2. Those were lectures 10 through 18, and then 30% on the newer lectures, which were 19 to 24. A big disclaimer here is that I can never guarantee these numbers to be exact, but that's going to be my thought process. Note, in some situations, I can combine topics, which is a good sign of a good final exam problem, wherein I take in concepts from computer architecture and try to relate that to operating systems. So asking a question which overlaps content that we covered in those two topics. But that's going to be my go-to in terms of a rough approximate. And in my opinion, the newer lectures, the 30% of the newer lectures, most people are going to find it relatively comfortable because, one, you recently went through these. Two, these are more theoretical, not so many calculations. But that's my preference. That's my opinion. Your opinion might actually be the reverse. I feel very comfortable with calculations, but the theory is where I get lost. So you will have to evaluate these things in terms of preparation for your strengths and weaknesses. Okay. Now I'm going to allow you guys to, well, not allow. I'm just going to open it up for a question answer session. So feel free to use your the chat box, or you can use your microphone, whatever works.
Hey, Professor Mead, I had a question about one of the homeworks from the past. I'm trying to find out in grade scope because I don't remember exactly which one it was.
Okay.
It was homework 5.
Okay.
There was a question, the first question about byte address, not byte address, sorry. You took the byte address and you made it into a word address, and then there was also taking the byte address and making a block address. Can
Yes.
you go over that again? Because that's like hazy in my memory.
So here, a lot of people got confused because of that, and the main confusion is because splitting up things into words is not necessary. So the confusion about that is there are blocks in the memory, but I don't necessarily need to break up those blocks into words and access things a word per word. I could have a memory in which I simply have a block and then I use certain bits to access bytes inside a block. So there are two approaches that can happen in terms of memory organization, right? So one is I will have blocks inside that I will have words and I will use bits to indicate which word I access. And in fact, I can go down even one more level and say I want to be able to access bytes within that word. Or a second approach is essentially your first problem on the midterm two, where you have a byte offset or block offset where you're just trying to access a byte within a block. So there is no splitting things up into words.
Okay.
So
So,
so it
okay.
depends on the context of the question, whether you're using those offset bytes to access bytes within a block, or are you using it to access bytes within a word. So the moment you say bytes within a word, then you will have to bring in words into the picture.
Okay.
Uh,
So,
I,
so like in the first question, it says direct mapped word level cache organizes 4 4K one word blocks. So
uh,
in that case, we're accessing a byte within a block.
this is the exam problem. Is that right?
No, this is CANOS homework 5.
Homework 5. Let me just open that
That's
up.
the first one on the homework 5.
Go down, 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 down. Oh, right. So, right. So the word address that you see over here,
Hmm.
so those are going to be the address of each word, right?
Yeah.
So you have a byte address, you have a word address. So each word address is broken up into a tag bits and cache index bits. Uh, I forget all the details on how each thing is organized, but this is essentially looking up the lecture notes for how certain bits are associated with the tag bit and cache index bit.
Okay. So it's one of the memory lectures.
Yes, so I believe it's the first one.
Okay.
But the point to note over here is it is talking about words.
Okay.
And question two also talking about words, right? So the words are present. So words is essentially how this memory is being organized.
Okay.
Uh,
Even though it says block address, even though it's looking for block address, you're still talking in terms of word like
right.
16 word blocks.
So because the words are how it is organized, so you're taking a block, chopping it up into words, and each word will have 4 bytes.
Hmm.
So that is not necessarily the case for all the memories, right? So you could just have blocks and bytes within the blocks, and I just need uh, a byte offset, and in this case you can call it a block offset to pick out each byte within a block,
Oh, okay, okay.
right?
So it all depends on whether on how they organize the cache.
Absolutely, yes.
Okay, that makes more sense.
All right, so there was a question on the chat regarding when is the test. Okay, so Thursday, May 7th, the time is going to be starting at 12 noon and it'll be due at 11:59 p.m. So a 12-hour time block. The exam, however, will be written as if it's a 3-hour exam, although a 3-hour exam, because you're taking this at home and you want to absolutely be sure of your answers, will tend to take longer than 3 hours. So i- it's not taking longer because um, it is written up. as a longer exam is just going to take longer because you want to be absolutely sure of your answer and you want to take those steps slowly. Okay, so we talked about this. Okay, other questions, guys?
Just a quick one. Will the test have like with deadlock? Will we be like looking at code, like the C code and trying to determine? No, or sorry, not deadlock. Sorry, the
The
pipes.
the, the pipes, yes, yes,
Yeah.
yes. Oh yeah, yeah.
Will we be looking at like C code and trying to determine like the forking and communication between processes? Or are we
Y-
trying to do stuff like that from the last homework?
yeah.
Okay.
And I thought in the lecture, and this is my opinion again. The biggest challenge that I'm facing right now is I don't know how much is getting through to the students. So I make a lecture, I post it, and you guys ask me questions on Piazza. However, there is still, that aspect of an instant feedback that I get from the body language that is missing. That I used to have in class. So,
Mm,
um, for that particular question, I would say take a look at that video where my goal with that particular pipes example was to walk you through each line of code. So in my opinion, I walked through it very slowly and in a lot of detail. But
yeah.
if for some reason, if you have any concern about, hey, why did he say that, let me know and I'll clarify.
Okay. I was just wondering, make sure that it was like the what we would be getting from that section.
Right. Yeah. 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 So pipes, questions on pipes can be of two types, right? One is a very theory based, like answer this question, explain this thing, or it could be, a C code, follow like
Mm,
just exactly how you did it in the homework. The
okay.
biggest confusion that comes from that pipes example is whether you are writing and reading from standard IO or whether you are writing and reading from the pipe file descriptor. So we were using one for the standard IO, 1 and 0 for the standard IO, and then we were using pipe FD1 and pipe FD0 to communicate through the pipe. So that's essentially, again, in my opinion, that's where the main confusion about that example can happen.
Okay.
All right. Mm. So while I wait for questions to come through, um, I want to say that I miss you guys. I miss interacting with you guys in class a lot. Um, Tim, Jeremy are there. I don't know. The third one is missing.
He's here. It's Ryan, I think.
Oh, it's Ryan. Oh, it's okay. Well, I know your name now. So Tim and Jeremy took some classes with me, so I know them from. All right, so yeah. See, I want to see more of you, but I also I'm very concerned about when we will be able to see each other. Um, So summer is done, so everything is online, and moving into fall, it is looking a little bit dangerous for the fall. So they're talking about hybrid. I don't know. So so after this class, yes, yeah. After this class is done, I would request you to give me feedback about how I can be a better online instructor, because you know I would like to believe that my in-person class is a lot different than my online class. So if there is anything I can do to kind of bring those two together, let me know. And you don't have to do that right now. After your finals week, when you have time, when you're relaxed, well, a little bit relaxed, you can give me the feedback then, and I will be asking for that feedback on Piazza. But that's very valuable to me going forward. So I'm talking about all these things that are not relevant to the final exam while I wait for questions from you. So uh, feel free to jump in.
So we know all of the different CPU scheduling methods, including PPS and round robin.
Yes. So CPU scheduling methods, we looked at the preemptive priority scheduling, right? Like we did an activity on that as well.
Yes.
Yes. But I guess in terms of round robin, we looked at only the theory. We didn't go through some problems, but we looked at the theory that goes along with the round robin scheme. I think that was the last slide on that lecture.
Yeah, I was wondering because it seemed a bit disconnected from the lecture, but it was on the activity, so I wasn't completely sure how much we should consider it when it comes to studying.
Well, so I would say this, right? In round robin, one, do you know why that is helpful compared to the first come first serve, for example? Why is that round robin scheme helpful? The reason is I want to be able to work through several of my processes. I don't want a process to hog up all the CPU resources. So the one way I can ensure that is to essentially go around in a circle, right? Like just okay, you take some quantum time, and then you take quantum time, and then um, so I would start with the algorithm part of it first, and then once understand that algorithm, it's just a matter of plugging in numbers. So uh, there is the one numerical example that we went over during class on round robin, and if you are able to understand all aspects of it, you are in good shape.
All right, perfect.
Hey, Professor, I was
Yeah.
just looking at the deadlock slides.
Yes.
I know you said to know the stuff about the detection algorithm and dealing
Yes.
with deadlock. Are we gonna see resource allocation graphs?
Uh, yeah, yes. I thought that was the the this. So let me rephrase that. Was there any particular difficulty with the resource allocation graphs that you faced?
Um, I just got confused about because we got to the part with the cycles, right? And the
Yes.
different processes within
Yes.
each resource or
Yes.
different instantiations.
Yes.
It's if you have a cycle when there's multiple instantiations, that means you won't hit deadlock, right?
You
Because you
may.
have multiple, you may.
You may, yes. So whenever you have several instances, then you have a way out, right? Like you can get out of the deadlock. And the only way to monitor that is by going through that banker's algorithm. So my answer would be, even if there is a cycle, but you have several instances of each resource type, then you may or may not have a deadlock. But if it is single instance per resource type, then you are guaranteed. If you have a cycle, you're done. So
It's just less likely if you have multiple instances.
yes, less likely. You are right.
All right, thanks.
No problem. So just as sketching up all those resource allocation graphs in PowerPoint actually was a very good mindfulness exercise for me. So I went through just several minutes and hours of sketching things very nicely as a mindfulness exercise. I don't know what you guys think about the color palette that I evolved over the semester. So going from the white background to a slightly darker background.
Looks very, very nice.
That's my 1 a.m., 2 a.m. and that's what I'm doing right now. Playing with color palettes.
I would note, Professor, that I use the presentation slides. I take the figures off the slides, and when you use the dark background, I have to remake the figures myself. So
You saw that, right? I spent a lot of time, and that's what I'm saying. That was mindfulness for me, because that just kept my mind on that instead of worrying about everything, I guess. That was a mindfulness exercise for me. So at some points I couldn't do it, but whenever I had time, I sketched up things from the beginning. Just don't use your thinking brain. Just draw. Yeah. So I understand your point completely, Tim. Yeah, I know. As a programmers love the dark mode. Yes.
There's one thing I'm having a lot of trouble with in this class as a whole, which is I have a lot of trouble tracing the data path.
Tracing the data path.
Yeah, when tracing MIPS instructions with data path. Do you have any advice for that?
So we can actually set up a time to go over an example. I can walk you through certain aspects. The data path, it's not necessarily hard, is what I'm trying to say.
Got it.
So we can set up a time sometime. I don't know. It's going to be a little bit difficult. So let's see. Do you have time to do an example now? I have trouble with that as well. Let's do this. I have another appointment at 4 o'clock with a faculty member. So how about if I take a look at an example and then make a short video and post it. So this is data path, right?
Yes.
Okay. Specifically on data path. So no pipelining. This is before the forwarding and all those were implemented.
Tracing is probably what I have more trouble with than even forwarding. Okay.
So I will set up an example, walk through the data path example, and I will post that.
All right. Thank you.
No problem. Yeah, I'm in a little bit of a time crunch. because we are trying to get ready for summer. We are getting ready for fall, so meetings to set up fall courses has begun. So all right, guys, other questions? So like I said, this video that we record, it'll be posted on YouTube. So if you want to review the review, you will have an opportunity to do that online. All right, so let me stop the recording first.